Thank you very much. For anyone who doesn't know me, my name's Derek Colley. I'm a SQL guy, a data guy. Been doing it now for just a little over a decade. So I went into contracting some time ago, and eventually I bumped into Adam. As you say, now I need a loyalty card, really. I think I've been with you guys for a while. So the purpose of today's session is a 30-minute overview, and it's not going to be all dry text. There's a little bit of demonstration, a little bit of video in there as well, just to give you an idea of what the general idea of a database is, what it does, how it interacts with the world as you know it. And take it away from this being this really dry, abstract thing that you see on paper or on LinkedIn and turn it into something that's a bit realer. So, just to kind of set the scene a little bit, everything that you do with technology, in fact, almost everything that you do these days is underpinned by a database. So if you use a key fob to get into the building, you will beep the key fob with your card, and the record of that transaction, that's you coming in, will head off to a database on a computer somewhere in the building. At the end of the month or at the end of the year or at regular audit intervals, they might want to go through and see, for example, who entered and when, if there's a police investigation or anything like that. All that data is there to be used. If you go to Costa's or Cafe Nero or whichever is your poison of choice, you go into a coffee shop and you buy something, you use an EPOS, electronic point of sale. So when you buy your coffee, the record of that transaction goes into Costa's database systems. And they know which is more popular, flat whites, cappuccinos, and so on. So all this data continues to flow, and there's this huge amount of data going on all the time behind the scenes, like the lifeblood of technology. Whenever you log into your computer and so on, there's a few examples there. Now, there's two differences in data. There's small data, and that's data that you might generate from writing a shopping list, because anything is a database. A shopping list is a database. And then there's big data, things like Netflix. If you consider Netflix has 130 million subscribers, and that you download a huge amount of data every evening. Now, not every subscriber will be on every evening, but the sheer amount of data volume that they have to generate and to broadcast to their subscribers is massive, and they've got a huge operation. So there's small data and big data is a really in vogue term at the moment. So where does the database fit into this? I mean, not all data is useful. Generating data on, for example, Costa coffee and what coffee you buy in the morning is useful to Costas, but it's not useful to anyone else. So data in terms of the organisation, that's your clients and the people that you speak to every day, depends entirely on how the organisation is set up and what they do. The company that I'm currently with is a car finance institution, so they're interested in how many people visit the website, how many people click through onto a certain link, how many people make an application, what their average credit score is. What sort of vehicles do they like? What's their demographic? What age are they? What gender are they? Where do they come from? And all that kind of information gets pumped through the database and then reformed, transformed even, into a form that the business can use, and that is an intelligent interpretation of the data. And we call that business intelligence, and that's a term you might have come across as well during recruitment with the BI. So the crux of all of this is the RDBMS, the Relational Database Management System, and that is the shorthand name for the entire software suite that makes up data management. Data is essentially, as you imagine it, if you think of Excel, you've got rows, you've got columns, and you've got tables. You've got different sheets in Excel. That is almost exactly how data is represented under the covers. SQL, SQL, structured query language, and this is, and all it is the language that you use to query data. So you can't use English. You can't say I want to see all flat whites sold at Costas in the last 6 months. You've got to put that into some kind of form that the machine can recognise and can bring back data. So that's what SQL is for. And there are a few different types of SQL that you might have seen in job postings and people's CVs. You've got Transact SQL and you've got PL SQL. Transact SQL is Microsoft's interpretation of it. PL SQL is Oracle's interpretation of it, and it's all based on a standard called ANSI. So when we talk about SQL, that's all we mean. We mean the language. How good are you at the language? So if someone says, I've got 5 years experience in T-SQL, great, we expect you to be very good at it. If someone says, I'm not very good at T-SQL, but I'm great at BI, that's a different skill set. So a really basic demo here. I'm not going to get too bogged down with the code and things like that, but I do want you to see what it looks like at the coalface, as it were. Now, I like my horse racing. I'm really keen on horse racing. So I have a little procedure at home, and it goes to the Sporting Life website every day, and it scrapes all of yesterday's data off it. That's all the horse races, about 150 a day. All the runners on those horse races, the going, the race courses, and so forth, everything. And then I filter it and put it all through into my database, which is hosted on Azure. And the reason is because I'm a total geek when it comes to horse racing stats, so I can have a look and go, oh, I wonder what might win today. And I might make a few quid. So I can do all this in SQL Server. So you can see I'm connected up here to my cloud server, horses server up here. And all we do with SQL is we either retrieve data or we push data back into the database. There's not really much else we can do with it. We can transform it and view it in different ways, but it all boils down to collecting the data and pushing it back out again. So in this horse racing database, these are all the runners, for example, and you can see down the bottom where it's executing. There's a few 100,000 rows, I think, at the last count. And I'm collecting all sorts of different information here. And this is the simplest type of SQL query that you can do, really. Bring me back everything. I've got 287,000 different horses there, going back over the last 5 years. So really useful if you want to find out what stables, for example, are doing best. Then we've got more complicated queries, so like the one I've got highlighted there, and that one's saying, I just want all the records I have from Lingfield on the 25th of September, and can you bring it back in order of race, please? And I'm going to join two tables together to bring back only the information I want. So that, for example, could be useful because I can see which runners run on a particular day. There's another way that you can view data as well, and this is used quite a lot by applications, called a stored procedure, another term that you might find in the CV. So I can write stored procedures. Stored procedures are basically code blocks that you can run over and over and over again. So here's a stored procedure to get all of yesterday's results, and when you run it, it brings back all of yesterday's results. Dead easy. And we can call stored procedures very straightforward, like this. Watch it bring back no data. No, there we go, it worked. So we have all the races, all the horses, and all the race course names that ran yesterday. So that essentially is SQL in a nutshell. You've got your Object Explorer on the left, you've got your code on the right, and your results down the bottom. And that really is the coalface of SQL Server. That's what everybody uses to get into it. Applications, websites, and so on, they connect to it slightly differently, and we'll see that in a minute. Let's just get this slideshow going again. Okay, so let's talk about business intelligence. So business intelligence is a slightly different term. We have our relational data, that's our online transaction processing data, and that is our raw data. That in Costa's terms is who bought what coffees at what times. But we want to aggregate that data. We want to know, how many coffees were sold on a particular day, which branches are doing better than another. And that's the really intelligent part of data. So OLTP is the term for collecting all the raw data, and OLAP, which is the analytics processing, is the transformed data that's useful for reporting and visualization. So that is essentially it. The BI stack in Microsoft terms, these are all terms again that you might have seen on CVs. We've got SSIS, which is integration services, and that's ETL. ETL means to take the data, transform it, and put it somewhere else. Extract, transform, load. You've got SSAS, which is a slightly different term, which means to consolidate and twist the data in the shape that you need it so that you can report upon it. And then you've got SSRS, which is a reporting mechanism, and you've got Power BI, which is data visualization. Oracle stack is slightly different, it's got two real components to it, so you've got Oracle BI and Oracle Data Visualization, but it's the same principle. And then we've got a few new market entrants like Tableau as well, again a term you might have seen, and that's all data visualization and a built-in analytics layer that all lives on the cloud. So that's BI in a nutshell. Essentially you have these add-on products to the suite that take all your data, twist and transform it into the format that you need and push it back out in the format that you want to view it in. This is the most complicated slide of the whole set, so don't fall asleep just yet. Okay, the application stack. You'll be familiar with this in some form or another. Here's Johnny, website user, going on to Facebook. Okay, so Facebook, the presentation layer takes care of colours, fonts, layout, whether it works on mobile, whether it works on desktop. It's everything that you see and touch on a website. Underneath that, you've got to have something to give it some functionality. So when I hit the like button in Facebook, I want that to actually do something. And in the business logic layer, the like button might say, add 1 to the score of this particular post, and this particular post will either go up or down in the rankings. The application layer makes the business logic layer happen. So the application layer says, okay, I'm going to get all the pieces together, I'm going to find out the score of that post, I'm going to add one to it and get the result. A data access layer is a bit different, and it's a bit out of scope of our conversation here, but it's a way of making sure that the application can talk to the database, because they've got two very different paradigms. So the application is what we call object-oriented, which means it's vertical, and the database is what we call relational, so it's horizontal. So all the DAL does is use things like entity framework, hibernate, again, terms that you might have seen in CVs, to make sure that the application has an interface to the data. Then we have the database layer, which I've blown out on the right-hand side there, and I'll talk about that in a moment. And the infrastructure layer is the physical tin. So that's your hard disks, your servers, even your cloud VMs. Now, expanding out on the right-hand side of the database layer, you've got a few different bits in the data stack, and we've talked about these already. So at the very bottom, you've got the database engine. That's our SQL Server coalface. That's our horse racing data. That's whatever we're working on. Our ETL layer transforms the data, and we'll see a bit about that in a minute. And our analytics layer twists and turns the data into the format that we want. And then our visualization layer shows it to the user. The management typically enter this stack at the very top here. Okay, so a very quick demo of SSIS. So SSIS is done in Visual Studio. Visual Studio is a tool that is used for software development on the .NET stack primarily, and it can be used for things like data tooling, which is why we're using it here. So going back to our horse racing data, I've got a very, very simple little ETL process here. All it's doing is it's emptying a table for me, and then it's going to go through some data that I've got stored in a file, and it's going to import it into the database. So here's my data. I've got about 50 rows. These are all horses, particular times, and this is where they came in the running order. Now I want to filter out these to only show winners, because I'm interested in what horses won a particular race. So a really, really simple example of using ETL is to suck in that file, filter it through and pop it into a database so I can query it and perhaps feed it into a report. So we've got two elements here. We've got the prepare the table and then do the work. In the do the work element, we can drill down. Resolution's appalling, so bear with me. And we've got three elements here. So this is a pointer to my file that I've just opened there. And then we've got something to filter out the winners. That's our transform, and that's our load at the end. So if I run this, and this is typically where my demos tend to fail, but we'll see. I should get three nice little ticks. Oh, I've done the work, fantastic. And you go, great. So you can go back to your database and we can have a look at our race winners table. If I selected it properly. And we've got all the winners out of that file, dead easy. So that is a really, really small example of what goes on in organisations on a scale of hundreds or even thousands of procedures. And if you think about what this kind of technique can do, you can really get a great deal of value out of the data that a business holds. So let's just put this back on again. And okay, SSIS. I'm not going to dwell on SSIS. SSIS is a completely different paradigm, a completely different way of envisioning the data that's stored in tables and rows. Instead, it's stored in something called cubes. And the only way of envisioning a cube is that if you compress the data and aggregate it the way that you want it, and then you imagine slicing the data by time, you end up with something that looks like a cube. I'm not going to read this slide out for you, but essentially you've got two different models, and you might see these on CVs as well. So multi-dimensional SSIS and tabular SSIS. SSIS is not the most common skill set on the market. It's going out of fashion to an extent because of influences of Tableau. Multi-dimensional also it's an extremely hard set of concepts to kind of understand. So Tabular is the rival model that Microsoft pushed out and said, oh, guys, this is easier, you might like it more. So we've got a few bits of terminology there that you might have seen before, and as I've said, Tableau is an all-in-one. And a very neat, colourful little diagram, not mine, that shows how a cube is put together. So here we've got a typical shop, so we've got salespeople, the items sold and the brand, you can see all the individual values, and then by branch. And what, if you can imagine this, if we wanted to know, for example, whether trainers were popular at branch 3, and who was the top salesperson in branch 3 that sold trainers, you could draw a line through his cube, you could draw an arc through the cube and say, okay, I want all of that data, add it up for me, please. That's what SSIS does. So a real quick video. 60 seconds of Power BI. This is data visualization. Let's just expand that. Oops. Not working very well, is it? Bear with me a second. I think PowerPoint's been a bit greedy. Bear with me. There we go. Okay, so that is one popular product. Tableau is another popular product. These are all designed to allow users to access their own data, so users can drag and drop, and it's a really shallow learning curve for them as well. So really, a really great set of options. So bear with me. Okay, so we talked about SAS, we watched our video. Meet the DBA. Okay, so DBAs are not noted for being particularly friendly people. I'm sure if you've spoken to a few of them, they can be rude, they can ignore your phone calls, they can refuse to pick up the phone, they can call you names, they can say, how did you get my number, and so on. DBAs are among the rarer types of database person. Developers tend to outnumber them, but they look after the whole data stack, so they're responsible for configuring, installing everything. I've put down at the bottom there built-in God complex, because I've never met a DBA who doesn't think they're the best at what they do, and nobody else can touch them in terms of their skills. It's all false. Everybody can get better at everything. But these are the guys. These are the go-to guys. So something's wrong with the whole data stack. That's where you look. They also tend to be, in terms of salary expectations, quite near the top of the tree. You've got SQL Developer. So SQL Developer is your typical application developer who's discovered what a database is and thinks, oh, well, you know, this is quite interesting. So they tend to have skills in other areas, .NET, Java, Python maybe. They write store procedures, they fix existing code. They tend to build stuff that makes the website go twing. That's what they do. They don't really get involved in the BI side of things. They're all about the code. Okay, and I've just put there again, beard and coffee optional, but that's more or less what they're like. So, BI developer, a little bit different. Okay, so BI developer is a SQL developer who's really good at maths, and they get involved in the ETL. They build things, they do the analytics, they present things, they get involved in linear algebra, they like to build reports. And Dilbert there is not far off actually, you know, saying, oh, this is fantastic, it's really geeky, and the management go, well, what can we do with it? They are not the same as a SQL developer. What I've found in my experience, I don't know if you can kind of echo it, there's quite a lot of fakers out there. A lot of people say, oh, I can do BI, I used it once, I saw a video. And it's quite a difficult skill to test because there's so many different things you can do with it. You can also get Tableau BI wizards, Oracle BI wizards as well. It is a developing area. And you've got the final one. These are kind of the rarest of the rare, and they only tend to turn up in larger organisations, so data architects. The business analyst is responsible for going to the business and going, what do you want to do? And the business go, more money, please. And they go, okay, right, you know, we can make that happen if we build X, Y, and Z. So they build X, Y, and Z, and they give it to the DBA, and DBA says, okay, let's build X, Y, and Z, and away we go. But in big organisations, sometimes building X, Y, and Z is quite a big thing to do. Imagine a new sort of a new version of Facebook. I mean, it's not something you can give to one person. So you end up giving it to an architect or even a team of architects. These architects bridge that gap. So they go, okay, I've got all the stakeholder requirements here. I've got what the DBA tells me we've got and our budget and what we can do. I'm going to glue it all together and make some formal designs, and then I can pass it along and get it built by the SQL devs. They are a bit of a rarity, but they're quite interesting to talk to if you ever encounter one. Near the end of this presentation, you'll be pleased to know. So, cloud versus on-prem, just worth saying that there are a few differences. By on-premises, we mean physical tin that you own. You put it into a cupboard, you put it into a data center. Okay, so it's your stuff. You host the data on it, but you're also responsible for updating it, patching it, Windows, even keeping the power on. Cloud computing is slightly different, and that's where you pay an external company to host all that for you, and they just give you the service. So if you go back to, if we just pop back to here to Coalface, you can see here I've got an Azure DB. So it's got an Azure network address. I'm not hosting on my local machine. I'll pay something like $5 a month for it. It's very, very cheap. Enterprise organisations can pay thousands a month, depending on how fast and how broad they want it to be. So these are what we call serverless architectures, and it isn't just databases Azure provides. So you've got all sorts of different services to do with machine learning. You've got Lambdas in AWS, you've got functions, you've got backups, you've got geo-replication, all sorts of different analytics tools. Azure Data Factory is a new thing that I need to learn. I know nothing about it, but it sounds quite good. And all these are available to price. It's very much like renting a house rather than buying it, but there's quite a lot of people coming onto the market now with these kind of skills, and there's a lot of demand for cloud experience. So, in fact, before we do that, I'm just going to show you one more thing. So this is Azure Portal. This is what we mean by cloud. This is our Coalface at the cloud. And this is the same database that we connected to earlier to try and cheat the bookies. So that's the front cover of it. We can do all sorts of things down here. We can replicate it across the world. We can set up new firewall rules. One of the things I had to do here when I got on the Wi-Fi was set up a firewall rule to say, you know, I'm not an intruder, I really am. This is my database. I'm just somewhere in Manchester. We can have a look at performance recommendations, we can expand it or contract it. And down here on the left, we can create all sorts of other things as well. So all our app services, virtual machines, cloud services, we can sort out security on the site as a whole. So it's a real one-stop shop for especially smaller organisations that can't afford the whole gamut of systems admin, hardware expert, database administrator, SQL developer, ordinary developer. A lot of companies can't afford that, so they go to this kind of solution. Coming back to our PowerPoint, final slide. So a quick recap on the terminology, and I'll make these slides available via Adam in case you do want to reference them, if you're that crazy. But there's a few definitions down here. The roles on the right, the typical roles that you'll work with, and on the left, some of the terminology that we talked about. And that's it from me. So any questions?
Derek?
No problem.